Okay, hello class. I'm going to start today with the preliminary notes to case study 2, part 1, where I go over the first 2 pages about errors and significance level. Okay, so welcome back to class. It's maybe been a while since you thought about hypothesis testing, so I want to go ahead and start with the philosophy of hypothesis testing. Okay, we start off our hypothesis test assuming the null hypothesis is true until our sample shows us strong enough evidence for the alternative hypothesis, okay? So we never have our entire population. We use this sample, hopefully an unbiased representative sample of our population that helps us make the decisions that you see here on the left, okay? Now, since we don't know the entire population, there is this level of uncertainty in that we don't always 100% know that we made the right decision. So I'm going to look over here in this underlying truth, okay? We wish we knew the underlying truth, but we have no way of knowing it. We would have to collect data on the entire population to know the underlying truth. We're running a hypothesis test because we cannot get to the entire population. So unless we sample the whole population, there is the potential to make an error. And that's what we're going to talk about here in this chart. So there are two potential decisions when we run a hypothesis test. We can reject HO and accept HA, or we can fail to reject HO. And there are two possible underlying truths. Either the alternative hypothesis is true or the null hypothesis is true. So let's start off with this first row. If we reject HO and accept HA completely, and HA is the truth, well, then that means our decision is correct. So what goes in this box here is the words correct decision. Okay. So if we reject HO and accept HA as the truth, but HO over here is the underlying truth, well, then that means we made some type of error. And what we're going to call that error is a type 1 error. Okay. So now let's go on to the second row, okay? If we fail to reject HO, now we never use the phrasing except HO. But if we fail to reject HO and we started off assuming HO is to be true and we didn't have evidence for HA, well, then we kind of just keep assuming HO to be true. So if I fail to reject HO and HO is the underlying truth, well, then that means we made a correct decision. If we fail to reject HO, it means we did not accept HA as the truth. So if we fail to reject HO, but HA is the underlying truth, then again, we made some type of error. And we're going to call this error a type 2 error. Okay. So now we have our chart filled in, and now I actually want to define, well, what is a type 1 error and a type 2 error? Well, a type 1 error is rejecting a true null hypothesis. Okay, so you see on the line, on the row where I'm talking about rejecting HO and accepting HA, if HO is the truth, well, I'm rejecting a true null hypothesis. That's a type 1 error. A type 2 error is failing to reject a false null hypothesis. Okay, so in this case, if HO is false, well, then our decision should be to reject HO and accept HA. But if we decide to fail to reject HO when HO is false, that means that we made a type 2 error. Okay, so just to kind of emphasize what I have at the top here about the underlying truth is that we will never know if we make one of these errors. The only way we can know is to sample the entire population. And if we can sample the entire population, we wouldn't have to run a hypothesis test to begin with. Okay, so I want to recall our courtroom example that we talked about, or maybe like the third week of class, whenever I was first introducing hypotheses to you. Okay, so HO, the defendant is innocent. HA is that the defendant is guilty. Okay, and I want to talk about these HO, this particular HO and HA, in the term of our errors. Okay, so if the jury saw strong enough evidence for the alternative hypothesis, then they say, we, the jury, find the defendant guilty. If this was an error and the underlying truth was that the defendant is innocent, did they make a type 1 or a type 2 error? Okay, so if we have evidence for HA, strong enough evidence for HA, and we say we reject HO and accept HA, but the defendant is actually innocent, well, if we scroll up and we look at our chart, that means I'm on this row right here. It means we made a type 1 error. Let's go on to the second one. If the jury did not see strong enough evidence for the alternative hypothesis and they decided to fail to reject the null hypothesis, then they say, we, the jury, find the defendant not guilty. If this was an error and the underlying truth is that the defendant is guilty, did they make a type 1 or a type 2 error? So when we fail to reject HO, we've got one of two options. We potentially made a correct decision if HO is the underlying truth, or we made a type 2 error if HA is the underlying truth. That works the same for rejecting HO and accepting HA. We either made a correct decision or a type 1 error in that case. So if we fail to reject a false null hypothesis, that means we made a type 2 error. The next thing that we're going to move on to look at is examples with writing errors. Now I want to just kind of make a note that these numbers 1 and 2 and the examples with writing errors, this is going to help you with the practice that I have posted to D2L, which will then help you with the homework assignment titled Errors. So a research team is working to determine if the average time a long distance runner takes to run a mile is longer than 5 minutes. Write the hypothesis for the research question, a type 1 error, and a type 2 error. All right, so this is a problem where our research team is talking about an average. So let's think back to the parameter that we're going to use here. So when we're talking about averages, our parameter is mu. And I am wondering if the average time a long distance runner takes to run a mile is longer than 5 minutes, okay? That is gonna help me form my HA. So HA is gonna be mu is greater than 5, which makes our HO mu equals 5. So we got our hypotheses. That's the first thing I asked for. The second thing I asked for is a type 1 error. And something that I've found in my practice is I think it's easiest to write the definition of a type 1 error and then apply that definition. Okay, so this definition has two parts. The first part is rejecting HO and accepting HA. Let me get some colors going on in here. Okay, maybe not. So the first part is rejecting, and then the second part is that true null hypothesis. Okay, so then the first thing you're going to want to think about is, well, what does it mean to reject HO and accept HA? It means that we do have evidence for HA. So we do have evidence that a long distance runner's average mile is longer than 5 minutes. But HO is what is true. Okay, so I'm gonna go ahead and show this and kind of talk through it. So this first box here, we claim the average time a long distance runner takes to run a mile is longer than 5 minutes. So that pertains to what does it mean to reject HO and accept HA? And then we have this big but. It's a but because we made an error. We decided this, but we were wrong. So we claim the average time a long distance runner takes to run a mile is longer than 5 minutes, when actually the average time a long distance runner takes to run a mile is equal to 5 minutes. So again, I like writing the definition of the error and then addressing each piece individually. Okay, type 2 error, failing to reject a false null hypothesis. Okay, so when we fail to reject HO, it means we don't have enough evidence for HA. So we kind of just keep assuming HO to be true. So again, I would break it up into two pieces. What is failing to reject and what is a false null hypothesis? Okay. Failing to reject means that we claim the average time a long distance runner takes to run a 5-minute run a mile is 5 minutes. I don't know why I got some spaces in here. Ooh. Okay, so failing to reject HO means we're kind of just sticking with HO for right now. Okay, when actually, but we made an error. Okay, a false null. If our null is false, then that means the average time is longer than 5 minutes. So we claim the average time a long distance runner takes to run a mile is 5 minutes, when actually the average time a long distance runner takes to run a mile is longer than 5 minutes. I know errors might seem a little new and a little different. I posted some practice. It's a blank page and there's also a key. And I'm just going to keep reminding all my students, please reach out to me. I'm totally willing to schedule office hours out, like more time outside of office hours. So just go over these, talk things through, make sure you're getting these ideas. All right, so let's just go back to the top review real quick. So we have this idea of errors. We have two decisions we can make with our hypothesis test, and we have two possibilities for the truth, HO and HA. So it's going to be helpful to know this chart and these definitions. All right, well, again, we'll never know if we make one of these errors. And then here, starting with that first bullet, are just some examples to kind of help you get started with feeling out how errors work. Okay, so now I want to move on to significance level, because as of right now, I've just stated a significance level for you or told you to assume alpha equals 0.05 unless stated otherwise. Now's the time where we're actually going to learn, well, what is the significance level? The significance level, or alpha, is the probability of a type 1 error. So that would be like the definition. The definition of alpha or significance level is that it's the probability of a type 1 error. So we can write that in math syntax as alpha equals the probability of a type 1 error. Remember that capital P in front of the open parenthesis stands for probability of. I have mentioned the three common significance levels for alpha when discussing confidence intervals. We have three typical alpha values. Those are 0.01, 0.05, and 0.1. That's 1%, 5%, or 10%. Which significance level should I use for my hypothesis test? So in this bullet, this is where I'm going to discuss how the significance level ties in to an error. Once we set up our null and alternative hypothesis, at that point, we're able to write out our errors. Then we can analyze these errors and see, is one of these errors worse than the other? So I don't have too much space down here, so I'm going to come draw my little graph up here. So we've got this little chart. Okay, and at the top, we have what you fear. Okay, so we might fear a type 1 error, we might fear a type 2 error, or we might be somewhere in the middle. What we have on this bottom row is alpha, our significance level. And I wrote that just a little bit too close. The numbers, the common values for alpha, are what are going to go on this bottom row. So 0.01, 0.05, 0.10. So how you're going to read this chart is that if what you fear is a type 1 error, then you're going to go with a lower significance level, 0.01. If what you fear is a type 2 error, you're going to go with a significance level of 0.10, a slightly higher one. Now, if you think both of these errors are equal in severity, that's when you go with the middle option of 0.05. So if we go back up to this example, we're talking about an average time a long distance runner takes to run a mile. There is not a lot of background info on this problem about who is doing this research, what company or person is wanting to know this. And so with that in mind, these errors don't have a lot of severity. When we talk about what you fear, you want to fear if you're working for a company, they're going to be afraid of losing profits. So you want to make sure you're not going to make an error that will make anybody lose money. Now, the only thing more important than like a company losing money is, maybe a type 1 or type 2 error that results in death or the loss of life. And those are the types of things where you're gonna write your errors and it's gonna really sway you to either a type 1 is definitely worse or a type 2 is definitely worse. If you read these errors above and you don't instantly see one as worse than the other, then it's totally okay to go with 0.05 right in the middle. Okay, and that ends our notes on errors and significance level. Okay, so this was the preliminary notes to case study 2, part 1. The next thing that you should do is go on D2L, check off that you have watched this video, and go ahead and start working on the rest of that checklist I have there for you. Okay, well, I will pick up on this page 57, talking about descriptive statistics next.